Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos.
Right, let's have a look at this one. This was a question 4b from the 2015 paper. Let omega be a complex number such that omega to the power of n is equal to 1. I'm highlighting that because I tend to miss those little things. Omega is not equal to 1, and s is equal to 1 plus omega squared plus dot 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 omega to the power of n minus 1. Okay, use the sum for the formula of a finite geometric series to write the value of s in its simplest form. Okay, so geometric series, you're over here in the log tables, page 22. I'm just taking a screenshot of both formulas. Okay, when I read this question the first time, I actually thought that read the sum of an infinite geometric series, because if you look back through all the questions, that is typically the question they ask when they write it like that. Okay, so I went straight for this formula. Okay, A is the first term always, or is the common ratio. Okay, so A in our sequence, okay, that's our sequence, 1 plus omega squared plus dot 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 omega to the power of n minus 1. Okay, so when you have things that go up like this, omega, and then you have this number 1 at the start, okay, remember that that's omega to the power of 0. Okay, that's where the 1 comes out of. Anything to the power of 0 is 1. Okay, so it can make more sense in your head if you go omega to the power of 0, omega to the power of 1, omega to the power of 2, so on and so forth. And that's handy when you are working out your common ratio R. So remember, R is T2 over T1 or T3 over T2. It's basically one term over the one before it, okay? So probably in my Leaving Cert, I would have done T3 over T2, but it doesn't matter, and it would be omega, okay? Or omega over 1, if you do T2 over T1 will work either. Okay, so my common ratio is omega, and my first term is 1. Okay, so when I did this the first time, I subbed it into this formula because I read it wrong. Okay, and I got no further than that. Okay, there's no way I can simplify that. It doesn't feel right. I didn't do anything. I just literally subbed it in. So went back to reread it again and then read it properly this time to say that it's the sum of a finite geometric series. So this is an infinite one. That's why the infinity symbol is there. This is the finite one. Okay, so let's do this one. So s to the power of n is equal to a times 1 minus r to the power of n over 1 minus r. Okay, so when we sub into this one then, we get 1 for a, 1 minus my r is omega to the power of n over 1 minus omega. Okay, so I hope that makes sense. Then subbing in what I have here in green, omega to the power of n is 1. Okay, so again, when I got here, or now that we're here, that's quite hard to simplify as well. So go back, reread the question, see is there anything else you missed? And of course, there's the omega to the power of n being equal to 1. Okay, so we can write this now as 1 minus 1 over 1 minus omega. Okay, and 1 minus 1 is 0, so we have 0 over 1 minus omega, which is 0. Okay, so the formula for the sum of a finite geometric series gives me 0 for my answer. And that's it done.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.